Atoms are the basic building blocks of matter. They are made up of even smaller particles called protons, neutrons, and electrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. Usually atoms have an equal number of protons and electrons. This means they have a neutral charge overall. An ion is an atom that has gained or lost electrons. This gain or loss gives the atom an electrical charge. Ions are all around us. They are in the air we breathe, the water we drink, and even our own bodies. Ions are essential for life as we know it. For example, ions help our nerves send signals, our muscles contract, and our blood clot. Ions are also used in many different technologies, such as batteries, cell phones, and computers. There are two types of ions, cations and anions. Cations are formed when an atom loses electrons. This loss gives the atom a positive charge. Anions are formed when an atom gains electrons. This gain gives the atom a negative charge. The process of forming an ion is called ionization. Ionization can happen in several ways. One common way is through chemical reactions. For example, when sodium metal reacts with chlorine gas, sodium chloride, table salt, is formed. During this reaction, a sodium atom loses an electron to become a sodium cation, Na+. A chlorine atom gains this electron to become a chloride anion, Cl. One important property of ions is their electrical conductivity. Ions can carry an electrical current when they are dissolved in water. This is because the charged ions are free to move around in the solution and carry the electrical charge with them. Another important property of ions is their reactivity. Ions are often more chemically reactive than neutral atoms. This is because ions have an unbalanced electrical charge, which makes them more likely to react with other atoms or molecules. Some common examples of cations include sodium ion, Na+, potassium ion, K+, calcium ion, Ca2+, and magnesium ion, Mg2+. These cations play crucial roles in various biological processes, such as nerve impulse transmission and muscle function. Some common examples of anions include chloride ion, Cl, hydroxide ion, OHe, and sulfate ion, SO42. These anions are involved in maintaining fluid balance, pH regulation, and other vital functions in living organisms. Ions are essential for life. They play a vital role in many biological processes, such as nerve impulse transmission, muscle contraction, and fluid balance. For example, the sodium-potassium pump is a protein found in the cell membranes of all animals. This pump uses energy to move sodium ions, Na+, out of the cell, and potassium ions, K+, into the cell. This movement of ions is essential for maintaining the proper balance of fluids inside and outside of cells, which is crucial for cell survival. Ions are also important in many technological applications. For example, batteries use ions to store and release energy. When a battery is being used, ions flow from one electrode to the other, generating an electrical current. When the battery is being charged, the ions flow back to their original electrode, storing the energy. In conclusion, ions are essential components of matter that play crucial roles in both the natural world and technological advancements. Their unique properties, including electrical conductivity and reactivity, make them vital for various biological processes, chemical reactions, and industrial applications.